dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Hello Form 1s, welcome to our geography lesson. My name is Teacher Eric. We shall be looking at chapter 5, and under chapter 5 we shall be looking at humidity. Now in our lesson today we shall look at the definition of humidity. We shall also look at the types of humidity, and later on we shall look at the factors that affect humidity. We go straight to the definition of humidity, and in your own words, what do you think humidity is? Well, I think from the previous lessons you must have looked at instruments, or an instrument that is used to record humidity, and we said hygrometer was the instrument. But what is humidity? We said humidity is the amount of water vapor or moisture in the atmosphere, like it is here, that humidity is the amount of water vapor or moisture in the atmosphere. Good. Now, this water vapor, where does it come from? This water vapor comes from the water bodies, the sources of water. And here we have rivers, lakes, oceans, we have even the seas. Now, look here, for example, most of you must have seen these. It can be equated, it can be looked at as sometimes mist or fog, but to an extent it is actually humidity because it is water vapor, right? So water vapor that is evaporating or actually going to the atmosphere, this is humidity. So we've said this class that humidity is the amount of water vapor or moisture in the atmosphere. We shall also be looking at now this water vapor in the atmosphere is obtained through evapotranspiration. Now when we were looking at water cycle, the hydrological cycle, we looked at the word evapotranspiration. Evapotranspiration is a combination of evaporation and transpiration. Evaporation, we know, when water evaporates, while transpiration, this is now the loss of water to the atmosphere through the stomata, the leaves, you know, the stomata, the small holes found in the leaves. Now, hot air is capable of holding more moisture than cold air. And definitely, whenever temperatures rise, then there's hot air. Hot air is obtained whenever there's an increase in temperatures. We shall go straight to something else, and here look at also a picture that is showing humidity. What happens is that whenever there is evaporation, as you can see here, something happens. Water vapor rises to the atmosphere, and as it rises, it goes and forms, it hangs in the atmosphere, and that is what you call humidity, water vapor. Now, this water vapor can be obtained through evaporation, as you can see the water body here, or the plants, transpiration. Well, next here, there are two types of humidity. There are two types of humidity. One, absolute humidity. Two, relative humidity. Now, absolute humidity is the actual amount of water vapor that a given mass of air can hold at a specific temperature. The actual amount of water vapor. And we shall look at the definition here that we've said, that absolute humidity is the actual amount of water vapor in a given mass of air at a particular temperature. The actual amount of water vapor, sorry. Now, relative humidity, on the other hand, is the ratio of absolute humidity, right, to the maximum water vapor that this mass of air could hold at the same temperature. Now, in a nutshell, what we are talking about is this here. For example, that whenever we have, whenever we have, for example, here, the atmosphere up there, the water vapor in the atmosphere here. This water vapor is what we refer to as humidity. Now, what happens is this, that the actual amount of water vapor that this mass of air here can hold is absolute humidity. But the ratio, you see, here the atmosphere as it is just a mass of air, a mixture of air. It can hold some certain amount of water vapor, maximum. Now, the ratio of this absolute humidity to the amount of humidity that can be held at a given time. For example, this atmosphere here can hold certain amount of water vapor to its full. So this ratio of absolute humidity, okay, to the total amount of water vapor that can be held is what you call relative humidity. So it's a ratio, it has no units. Now, absolute humidity is usually measured in units that we call grams. Normally we have here we have grams per meter cubic. These are the units for measuring humidity, absolute humidity, grams per meter cubic. Now, we shall look at here, as we have said, that the two types of humidity are absolute humidity and relative humidity. Now, the next thing that we shall look at is the factors that affect humidity. What are some of the factors that can cause humidity to go up or humidity to be low in the atmosphere? Now, as we shall be looking at them here, the first factor that we shall look at is temperature. And among others, apart from temperature, we shall also look at latitude, we shall look at air pressure, we shall also look at the supply of moisture. Now, temperature here, it has to be clearly stated that whenever temperature increases, right, then the absolute humidity will go up. And as absolute humidity goes up, that ratio decreases. That means that now the relative humidity will go down. This is what happens, that when, for example, the water vapor content remains the same in the atmosphere with an increase in temperature. Increase in temperature means that the air has to expand, and as it expands, the volume increases. This volume allows water vapor, large amount of water vapor, to be held. So increase in temperature lowers the relative humidity. Relative humidity, and the key word here is relative, but the absolute humidity will be up. Now, if the water vapor content stays the same, temperature drops and the relative humidity increases, and vice versa. So what we are saying is that whenever there is an increase in temperature, the relative humidity goes down. And when there is decrease in temperature, the relative humidity goes up. Remember, we are talking about relative humidity. Right. Next, the next factor here is latitude. And you know very well that the main latitude that subdivides the northern hemisphere and southern hemisphere across the globe is the equator. So this means that places that are far away from the equator have high latitude, or we refer to them as high latitude. Equator is known to be low latitude. Now, this is how it affects humidity. Humidity is higher in low latitude areas than high latitude areas. Areas near the equator, air is warmed up faster than it is to the other sides or to the other poles. So that means that where the air is warmed quickly, I'll just use an illustration somewhere here on our map here. For example, we have the equator. Equator is this line here. Here, the equator crosses here. Sorry. The equator crosses here. Here it is. It is low latitude, and that means that places that are close to the equator normally are warm, and if they become warm, it means that their humidity, their volume expands, because when air is heated it expands and it has large volume, and therefore that means that it is going to attract large amount of water vapor. Good. What about places which are away from the equator? Well, you have the answer, that humidity will be low to the other places. That's what you said, and it can be seen from the illustration here, from this illustration. From this illustration here, it can be seen that here humidity, as we said, is higher at low latitude than at the higher latitude. This is because there is greater rate of evaporation in the lower latitudes. Now, the warmer air, like we had said initially, the warmer air becomes warm, and this warmer air here means that the temperature will cause it to expand, and as it expands, what does it do? It increases its capacity to hold moisture. Moisture is that amount of water vapor that you said, actually just water, so it increases the capacity to hold water vapor. Right, so class, we said about temperature. We looked at temperature, that an increase in temperature leads to reduction in amount of water vapor in the atmosphere. While we've talked about it, we also said that it directly affects the relative humidity, that when temperature goes up, relative humidity goes down. And we've also looked at latitude, that an increase in latitude, or at higher latitudes there is less humidity, but at lower latitudes there is high rate of evaporation, and therefore it increases the capacity of air to hold a lot of moisture. I think the other factor that remain, the two factors that remain, we shall be looking at them in our next lesson. We only have two factors that remain, that is moisture supply, and we also have something else, which is air pressure. Now, just to recap what we have said, we have looked at the two types of humidity, which is absolute humidity and relative humidity. Initially, we had looked at humidity as the amount of water vapor in the atmosphere, right? And that is the end of it. And at the end of this lesson, you're going to find some notes and an assignment for you to do. You know what to do. You have to log on to the website of Amano School, boarding and day school. Then you'll have to use your username and the password. You'll get the notes and the assignment. Thank you for watching. Have a nice time.